Hey guys, today we're going to talk about the area of a sector. Area of a sector is different than arc length. So if we take a look at our picture here, the shaded part is the area that we want to find. When we found arc length, we wanted to find the distance from J to L. Now we want to find out that shaded region, which is kind of like a slice of pizza. So we would want to find out how much area this slice of pizza is out of the entire pizza pie. So to find out the area of a sector, it's kind of like finding the area of a slice of pizza. So one thing we have to find out is the area of circle K. So remember, the formula for area of a circle is pi r squared. So if we look at our picture here, we see that 4 is our radius, and we just plug it in. Area equals pi times 4 squared. So 4 squared is 16. 16 pi, and our units are feet. Remember, when we do area, our units are squared. So 16 pi feet squared. Again, we are going to leave our answer in terms of pi. Let's make a little note of that. Leave answer in terms of pi. All right, I'll put a different bubble around that one, or a little box. All right. Okay, so now we want to find the area of the shaded sector, this red area. So in order to do that, we need to know the area of a sector formula. It's actually very similar to the arc length formula. So again, we're going to start off with x over 360 times, instead of the circumference formula, we're going to use the area formula, pi r squared. Again, x stands for our central angle. All right, so we're going to find the area of the shaded region. Let's use the formula. X over 360 times pi r squared. So our central angle is 53 over 360 times pi, our radius is 4, squared. So I'm going to bring it over here. 53 over 360 times 4 squared is 16 pi, like when you did arc length formula, we put that over 1. 53 times 16, doing our calculator, is 848. 360 times 1 is 360. Keep our pi and simplify. Use our calculators to simplify, and we get 106 over 45 pi feet squared. Remember to keep our units squared. Okay, so now let's take a look at a couple of examples. Now, each one of these examples is a little bit different than the next. So if we take a look at number 3 is just like the one we did. So let's practice this. Find the area of the shaded sector. So if we take a look here, I need to actually give you a little bit of information here because I forgot to put what the radius is. So for this problem, let's make the radius 5 meters. Okay, so if we're going to look at this problem, x over 360 times pi r squared. 95 is our central angle, over 360 times pi times 5 squared. 95 over 360 times 5 squared is 25. So we have 25 pi. Put that over 1. And now let's multiply 95 times 25. I get 2,375 pi over 360. So let's take a look and see if that simplifies in our calculator. All right, let me simplify that for you. And we get 475 over 72 pi meters squared. All right, so that was the area of this huge slice of pizza. Now, let's take a look at number 4. Number 4, the shaded area is not where we were expecting it like the last two. The shaded area is this enormous slice of pizza, almost the whole pie. All right, so like we did with arc length, when we knew that central angle is 65, we know that this is 65 degrees. So remember, there's 360 degrees inside of a circle, so let's do 360 minus 65. 360 minus 65 is 295. So arc JML is 295 degrees, which makes this angle inside here 295 degrees. All right, so when we plug this into our formula, x over 360 times pi r squared. X is going to be 295 over 360 times pi, and our radius is 11 squared. All right, so now we've got 295 over 360 times 11 squared is 121 pi over 1. 295 times 121 is going to give us a big number, 35,695 pi over 360. So this is great that we have our calculator because we can see if that reduces. Turns out that it does. 7,139 over 72 pi inches squared. All right, and that's your answer. Now, let's take a look at number 5. So number 5 is completely different than 3 and 4. Number 5, if it were a normal problem, we would want to know this slice of pizza. But that is not the shaded part. The shaded part is the black piece up here. That's the area that I want to figure out, just the black area, not where I've shaded the red. But if you notice where I shaded the red, that's a triangle. So we have to do something a little bit different here. This is going to take us a couple of steps to do number 5. All right, so let me kind of block off an area here for us to do our work. All right, step 1. Find the area of the sector. So we're going to pretend like we do want to find this whole big area like we did up in number 3. So first step is to do area of a sector. Write these steps down so that you can do this on your homework. So area of a sector we know is x over 360 times pi r squared. So take a look. X would be 90 over 360 times pi, and our radius is 10 squared. So 90 over 360 times 100 pi over 1 will give us 9,000 pi over 360, and that actually simplifies to 25 pi. Now, they didn't give us any units. If they don't give any units, just put u squared for units squared. All right, bubble your answer. We're going to need that in a minute. Because step 2 is going to be finding the area of the triangle. So now I'm just looking at my red shaded area, just the red. For area of a triangle, remember our formula is base times height divided by 2. So it's nice that it's a right triangle. If it's a right triangle, this is our base, this is our height. Well, 10 is the radius. Isn't this a radius also? So this is also 10. So it's nice and easy to plug into our formula. Our base is 10, our height is 10, and we just have to divide by 2. So 10 times 10 is 100. 100 divided by 2 is 50. And let's put units squared. Bubble that answer. All right, so last step is going to be subtract. So the two answers that you've bubbled, we want to subtract these two answers. However, this one has a pi with it and this one doesn't. You cannot subtract those two. So what we have to say is just 25 pi minus 50 units squared. That's how you write your answer. Okay, all right, last one. All right, so we're not going to do arc length right now. We're just going to do the area of a sector here. All right, now let's take a look. This is very similar to number 5 above. However, this one is not a right triangle. So when it's not a right triangle, it becomes a teensy bit little more difficult. All right, so make sure you're paying attention when we're doing this problem because you will have some like this for your homework. All right. So same rules apply. We want to do the area of a sector, we want to do the area of a triangle, and then we want to subtract. So first step. All right, let's cross off that we're not doing arc length. First step, area of a sector. So area of sector. So x over 360 times pi r squared. All right, so doesn't tell us the angle in here, but if we look at the central angle goes with this arc. So if this arc is 120, the central angle is 120. So that's what's going to go in for our x. 120 divided by 360 times pi, our radius is 6 squared. 120 divided by 360 times 36 pi over 1. 120 times 36 is 4,320 pi over 360. Oh, sorry. When you do that in your calculator, that reduces to a nice old 12 pi. All right, so I'm going to take my red and I'm going to bubble that because I'm going to need that in a few minutes. All right, second step. Area of a triangle. All right, now this is where I want you to put like a star by it because this is where it's going to get a little bit tricky. All right, for area of a triangle, we know that it's base times height divided by 2. The reason this was nice and easy is because it was a right triangle and that meant this was our base and this is our height. Remember, your base and height have to be perpendicular. If we look at this triangle, we do not have anything that's perpendicular given to us. However, if I draw a line straight down right here, that makes a 90 degrees with this piece. And we said that that central angle was 120 degrees. If I split 120 degrees in half, I get that this is 60 degrees. And the other side is 60 degrees. So what I'm hoping you see, and you may groan, is that this is 90, this is 60, which makes this 30. So we have a 30, 60, 90 degree triangle on our hands. I'm going to erase this 60 over here just to give myself a little bit more room. Okay, so remember, we need to now remember our 30, 60, 90 rules. So that's why I have a star by this, so that we can remember the 30, 60, 90 rules. I'm going to jot that down. We need 30, 60, 90. So remember, in a 30, 60, 90 triangle, this is the hypotenuse. This is the short leg. This is the long leg. Remember, there's a relationship between the short leg and the hypotenuse. The hypotenuse is twice the short leg. So if we have to go backwards, we would just have to divide by 2. So half of 6 is 3. When you know the short leg, in order to get that long leg over here, we have to multiply by root 3. So this becomes 3 root 3. Now 3 root 3 is just this distance right here. All right, so the problem is we have to figure out the area of this whole triangle. So we know the height now. The height now is going to be 3. But we need to know the whole base. So if this is 3 root 3, this other piece will be 3 root 3, which means the whole base would be 6 root 3. It's just like saying 3x and 3x would give you 6x. But 3 root 3 plus 3 root 3 is 6 root 3. So we know that our height is going to be 3 and our base is going to be 6 root 3. Now we can use that and plug that into our formula. Our base is 6 root 3. Our height is 3. And we have to divide by 2. So 6 times 3 is 18 root 3 divided by 2. 18 divided by 2 is 9 root 3. Let's bubble that. That is the area of the triangle. So our last step is to subtract our 2 bubbled answers. So step 3 is subtract. Remember, this has a pi symbol with it, so we cannot subtract them. We just have to kind of rewrite them. 12 pi minus 9 root 3. There were no units given to us, so I want to just do units squared. This right here is your final answer for the area of this shaded region. So what I suggest to you is when you're doing your work, your homework, you look back here because there could be a 45, 45, 90 triangle given to you. You have to go back and you have to remember those rules. Go through slowly and replay this if you're having trouble so that you can see how we did the 30, 60, 90 rules. Remember, if it's given to you like this, where you have a right triangle, then you already know your base and your height. If you do not know the central angle is 90 degrees, then it turns out it's either going to be a 30, 60, 90 triangle or a 45, 45, 90 triangle.